welcome to the stream. I hope you have a good week, a good summer so far, if you are in the Northern Hemisphere, and enjoying the temperatures and the sun. Before we dive in, I'd like to share, obviously, notes, 2023 information. We had the call for papers closed last Friday, and on October 26th, we will do notes this year. So even though if you probably or maybe you have missed the call for papers, we got lots of submissions, so maybe you're one of the ones that submitted. So thank you very much for that. And we are currently evaluating and checking out the submissions for that. But if you didn't want to submit, why? But if you just looking forward to attend the event, you can already register now. Let me post the link in the chat. So if you like to go and register, you can do so already. And yeah, that's our notes. All right, let's talk linguistics and NLP. So and graphs, a little bit of graphs as well, obviously. So Maria, maybe do you wanna say a few words about yourself, who you are, what you do?
Sure.
Yeah.
Yes, sure. So I am a linguist, more of a computational linguist, and I started using graphs many years ago, more or less in 2016-17, with
Okay.
my master thesis, because I was looking for a way to better represent synonyms to enhance speech recognition grammar for dialogue systems. And we had this system called multi-word net extended, where words were represented with their semantic relationships. And I started using this tool with graphs for my master thesis long ago. And then I continued also for my PhD. And as you'll see during this talk, I will give you some hints on what I did also for my PhD, for my dissertation, and how I also used graphs. In general, I can say that I more focused on pragmatics, which is a branch of linguistics that I also explain to you during this talk, what it is about and in what way the graphs can be useful to represent something concerned with pragmatics.
Cool. And you are at the University of Naples. You work with Antonio.
Yes,
Yes.
I work with Antonio Riglia. He had a talk, a presentation for you, I guess, in March.
Yeah.
And we are in the same lab, and we work together. And you'll see some things that maybe it was already mentioned during that presentation. But of course, I'll give you a more linguistic point of view. Yeah.
So yeah, Antonio, I had, and let me post a link in the chat. I had him a couple of months ago. We talked about conversational AI with Neo4j and the Unreal Engine. So he's developing, he's working on a chatbot system with a avatar-like representation you can talk to, and they give you answers back, and it's very cool and very interesting. So if you're into that, then check out the previous episode. And that's I guess, is this how you came in touch with Neo4j or came in touch with graphs? Is that via Antonio? Did he kind of say, hey, I'm doing this cool thing, and then you thought about, hey, this is interesting, or was it different?
It's all his fault.
It's all his fault. Okay,
yeah.
good. I hope there are no regrets.
He's the one that also implemented the graph that I mentioned before, this multi-word net extended graph. And when I first came into this lab, I was looking for something for my thesis, and there was this tool, and I started learning what graphs were and how I could use it for my research.
Okay.
Yeah.
I gotta ask this because in your in the little summary, I don't know if you watched I shot a little trailer about what's going to happen, and in your thesis also it talks about argumentation based dialogues, or dialogue where people are fighting about something. Is I mean, how did you come out, or you might maybe you mentioned this later, but I find this very interesting. I mean, how did you decide? Okay, I mean, I like to analyze arguments between people. Is this, how did you come up with that?
I guess it all started with conflicts in
Yeah,
dialogue,
conflicts.
because
Yeah.
my dissertation was about conflicts, specifically conflicts occurring in the common ground. We'll see later what these are, what type of conflicts are. And with this concept of conflict in mind, I started with also argumentation in general, because
Hmm.
argumentation is actually not necessarily something that occurs when a conflict occurs, but it could also be something related to the reach of a common goal. For example, in recommendation, the recommendation task is a type of argumentation-based dialogue, and in
Hmm.
this type of task, the goal is to find an appropriate item to recommend to the user, and all the arguments and the justifications that you can use to find the item and recommend it are all strategies that are part of argumentation-based dialogue themselves. So yeah, it started with
Okay.
conflicts, but now we're more peaceful people.
Okay. Okay. Good.
Yeah.
Cool. That's good. So I think that you don't just like to argue a lot. Good. All right. You had a couple of things prepared, so I think we are ready to dive in. Always open invitation to the audience. So if there are any questions, any comments, anything you'd like to go a little bit more into, then use the opportunity to type it in chat, so we can see that and react to that. Otherwise, you miss out. And yeah, with that, I think I can do this, and you are good to go, Maria.
Okay, thank you. So yes, as you can already see from this first title slide, there will be many Lord of the Ring references during this presentation.
That's good.
Yeah, it was something that maybe it was already anticipated in Antonio's presentation, because he mentioned Lorien and Angmar, which is now something different. We have Lorien and Mordor, you'll see.
Yeah.
And for me, this is really nice because it allows me to connect many concepts, even theory-based concepts, in a more creative way, let's say. In fact, I can start saying that this was for me an unexpected journey, because using graphs for linguists was not something that was previously expected.
Yeah.
I can also say, as you can see from the background of this slide, that for me, linguistics can be compared to what for a hobbit a shire is. So it's my safe place, the place where I can do my research in peace and everything. But like Bilbo Baggins, that could be something that can tempt you and corrupt you, like the ring, that can give you the power to do things you've never thought you could do. And here is where graphs take over. So in this presentation, I will show you what me as a linguist can also do by using graphs.
Cool.
So, okay. A bit of outline. I will start explaining what pragmatics is, and I will show you many ways in which we can represent, study, and model pragmatic phenomena, like corpus linguistics or the the current large language models, and also graph databases. And our graph-based corpus analysis can also replace the corpus linguistics that I'm going to explain to you in the first slides. Then, in the second part of the presentation, I will give you more details on our framework called ARLA, and how this can be divided into two different parts: Lorien, which is more theory-based, and Mordor, which is more about the technological implementation of what is explained in Lorien.
It's very on topic.
Yeah. Who am I? I've already gave you some indications. Antonio also told you how our lab work and how it works, and many figures that work here. So we have computer scientists, phoneticians, and people working on pragmatics. So what is pragmatics? We can say that in general, linguistics is a science that studies human speech from different perspectives. We can have language as a cognitive skill, language as a communicative tool, or language as a structure made of different units like morphemes, phonemes, and so on. Pragmatics is, on the other hand, the study of language in use or language in its context of use. Here we have our first important keyword, which is context. We'll see that context is particularly important when we talk about pragmatics, but also it is also important if we want to model pragmatics with graphs. What is a context? Context is the set of circumstances in which a speech act occurs. When we talk about pragmatics, we refer to utterances as speech acts, because everything that we do it to perform a specific action. Everything we do with the language, we do it to perform a specific action. Context can be of two different types. We can have a situational context or a communicative context. A situational context is the set of not specifically circumstances related to linguistics, but we can have extra linguistic information that can constitute the meaning of what we are communicating. So, for example, our interlocutors, the relationship we have with the interlocutor, or the set of shared knowledge with that interlocutor. Or we can have also a communicative context. The communicative context refers to the utterances and information which are shared during the interaction itself. So everything that we communicate during, for example, a dialogue constitutes the communicative and linguistic context. And we'll see that graphs are important to represent both types of context, because we can store the information collected in the dialogue, but we can also store the knowledge that are not specifically shared in that moment during the dialogue. For example, we'll see we can use tools like linked open data. So, NLP methodologies that can be used to study language in use, we can have, for example, corpus linguistics. Corpus linguistics is concerned with corpora. A corpus is a collection of texts selected and organized to meet specific criteria that make them functional for linguistic analysis, meaning that we can use this data, this text that can be annotated or not annotated, labeled or not labeled, to extract specific information. There are different methodologies, different techniques that we can apply to corpora to study language and to extract information. One of them is keywords in context. These allow the study of how, for example, a word is used in its context of use, to better understand the meaning that these words can have according to the context, according to the words this word can co-occur with. Corpus linguistics can also be used, for example, in conversational analysis to find communicative patterns and carry out both qualitative and quantitative analysis. Then we have large language models that we can say it's a type of corpus linguistics take into the extremes, to its extremes, because we can still use a large amount of data, of text, but this can be also unlabeled. And the thing about large language models is also that they are computerized language models and consist of artificial neural networks with many parameters. And we can use different learning techniques like self-supervised or semi-supervised learning methods. This means that we started with corpus linguistics, and then nowadays the data are mostly analyzed and interpreted statistically. And this is really important for quantitative information, but not always for qualitative information, especially when we talk about pragmatics. And we'll see why this might be problematic with pragmatics. So there are some limitations to this approach. First of all, we need a massive amount of data and of computing power. And of course, we as individuals or small organizations or in the academia, this is not always possible. We know that. And the other thing is that biases and prejudice cannot always be controlled when we use this data, this unlabeled data. And then again, the thing is that the analysis here is merely based on statistics. And although statistics can be useful to extract, for example, the best representation of some phenomena, linguistics, and more specifically pragmatics, deals with phenomena that are always contextually determined. And as we saw, context is really important for pragmatics. And this means that if a specific context is not well represented in the population or in the data that we are using for our computational purposes, this phenomena will never be considered numerically, even if they are, for example, really important for communicative purposes. So there are some phenomena that we cannot always be sure to capture. To overcome these limitations, another approach can be used to study and represent pragmatics or linguistics in general. And we can have, for example, graph databases. Graph databases can actually be really important for two main reasons. They allow for fast path search operations. Why this is important for linguistics? When we communicate, we share information on multiple terms. This means that the interlocutors construct and interpret messages considering the relationships between the previous messages as well. For this reason, we can go back to what we saw before. We can correct what we said before, or we can change our interpretation. We can refer to it, and so on. These actions in communication are always extremely important. And as we'll see in this talk, graphs databases can actually allow these processes. The other thing is that graph databases can also allow for cross-references. This means that when we communicate, we also refer to things which are not specific of what we are now sharing during the communication. There are some knowledge that are implicit because we know that they are shared with our interlocutor, and this can refer to the things of the word, for example. Graphs databases are capable to represent multiple resources and map them to one another. And this means that we can also refer to multiple things multiple related things while communicating, and this can be retrieved by using also a graph databases. So now we can go deeper in what we can actually do in linguistics with graph databases. The first step of this unexpected journey was starting to apply graphs for dialogical corpus analysis. So we asked ourselves what happens if instead of using simple corpus analysis, we use graph databases and all the things that we can represent in a graph database. And the first thing that uh, was retrieved by this analysis were the ring-like patterns. So here we started with all the references with the Lord of the Ring, with this big ring that we retrieved. Basically, in this ring, it is represented a pattern that is particularly important for argumentation-based dialogue, because here we have dialogue, a recommendation dialogue, again, what I mentioned before, and specifically the gray notes refer to the different utterances communicated in the dialogue, and these notes are connected to one another followed by relationships. And it happens that at a certain point of the dialogue, an actor, in this case we have Chris Evans, is mentioned, and later in the dialogue, a movie in which Chris Evans is starring is also mentioned, like The Avengers. This means that on the one hand, the dialogue is coherent because we are referring to things which are referred to one another. And we can do this because we have a representation of the movie domain with movies, actors, directors, and everything. And this means that also when we refer to something not present in the dialogue, we can refer to this set of knowledge, which is also represented in the graph. On the other hand, we can also use this pattern to disambiguate entities, because Chris Evans actually can be different persons. Different persons can have the name Chris Evans, but in this dialogue, we are referring to the Chris Evans starring in this movie. And with this pattern, we can be sure that we are referring to that specific person. This is something which is not directly possible with corpus analysis, and the use of graph can help us go deeper into the conversational analysis. Also to, as we saw, to uh, check if the dialogue was coherent enough.
So just so
Yeah.
to understand, because I think this is interesting, the green note is not the movie; it's the Chris Evans acting in the Avengers Endgame. There's is a person note, or is it the movie note?
This is the movie. This is the
movie.
person.
This is the person.
Yeah.
Okay, I see. Yeah. Okay. Yeah. Yeah.
And yeah, basically this query returns all the utterances and the entities which are related to one another and which are uttered within the dialogue. So the two nodes related to one another which are mentioned in the dialogue.
Yeah.
So from this, we started basing our framework on graphs. And as you can see from this slide, ARDA stands here for Argumentation in Recommender Dialogue Agents. And today we'll have a look at some of the character-based linguistic models that we represented in ARDA by using graphs. Our first distinction that we can make is between Lorien and Mordor, the previous Andmar. Lorien is about the use of graph for linguistic formalization and representation. And on the other hand, Mordor, as I mentioned before, is about the computational models that are based on the theory. Okay, Lovian can be firstly distinguished between Gandalf and Galadriel. Gandalf is about knowledge representation as far as both common ground and common sense are concerned. Common ground is here represented by Gimli and common sense by Celeborn. And Galadriel operates instead on the representing knowledge by formalizing specific pragmatic phenomena. For example, we have clarification requests in Frodo, explanation in Arwen, and recommendation strategies in Smeagol. As far as modeling is concerned, we currently have these two models, which are Treebeard with behaviors trees and Samwise that generates simulated dialogues for evaluation purposes and further implementation. As a linguist, I am more concerned with Lorien, and here we'll also have a look at some of the systems of the theories that are implemented with graphs. We said that Gandalf is more about the theory of how to represent a knowledge. So we have, as we said before, the common ground in Gimli and common sense in Celeborn. And then we have Galadriel, which is more practical, and it uses the knowledge represented in Gandalf to apply specific strategies in communication, like clarification requests, explanation, and argumentation strategies. Okay, we can start with Gandalf to see how the knowledge is represented in our view. So Gandalf refers to the guiding knowledge representation that travels through Lorien. And as a matter of fact, for the development of Arda, we consider three different graph-based knowledge types that are specifically common ground, common sense, and personal experience. Our first distinction that must be made is between two different types of common ground. For those of you who are not aware of what common ground is the set of shared knowledge among the interlocutors during an interaction. And we can have different types of common ground. The communal common ground that refers to the information shared with people belonging to the same community. So things concerned with the general knowledge about social background, education, religion, languages, nationality, and so on. And on the other end, we have personal common ground, which is established during the interaction. So the personal common ground refers to the knowledge shared during the dialogue itself. This personal common ground can also become personal experience, because of course all the knowledge that we learned from the interaction with other person can become our personal experience that can also help us in interacting with other persons. Okay. Another thing which is important here is the fact that whereas personal experience is represented by dialogue stored in the graph, also dynamically, so we can always add new dialogues to the graph. The communal common ground is here represented by knowledge coming from linked open data. And we'll see later which specific data we, for example, represented in our graph. Moreover, interlocutors can also use communal common ground to build beliefs or presuppositions. Beliefs and presuppositions are really important in dialogue because they help to construct the interaction and to interpret what we received from our interlocutor. Similarly, during the conversation, the personal common ground is also useful to build the shared knowledge, the shared beliefs that can also guide the interaction. Another important thing is the common sense that we have here. In the communal common ground, we can encapsulate the common sense. This might not sound really correct, but there is a reason why we represent this as in here, because common sense is the amount of knowledge of default assumption about the world, and it's something so fundamental, which is almost obvious, and sometimes is also left implicit in the dialogue. Why this is encapsulated into communal common ground? Because here this is a work in progress by one of our PhD students of the lab. She's Sabrina Mennella, and according to our view, we cannot really represent the entire knowledge that a person might have, the entire set of common sense knowledge. But what we can do is to use the knowledge that we have in a way that we can extract the possible processes and the processes that build the common sense. The reasoning we do on the knowledge that we have in a way. So what we think is that common sense is more a process rather than a representation. And this is also represented here by these dotted arrows, because common sense is not necessarily represented by relationships which are established in a knowledge base, but it can also be derived and reconstructed from nodes that can be related with a high probability. So if there is a high probability that something has a specific flavor, we have that knowledge as a common sense knowledge. Of course, the difference between common ground and common sense is still something which needs investigation, but we might say that in general, common ground is something which is partner specific, because we use this knowledge for a specific interaction, whereas common sense is more generic. Okay, what we saw now in Gandalf, which refers to, as we saw, Gimli, Celeborn, and so on. So common sense, common ground, personal experience is here represented more practically. We can summarize here the structure of our knowledge graph, which is based on Gandalf. And in this case, we have the movie recommendation example, because we have a system whose task is to recommend movies. And this task is encapsulated, as we mentioned before, in the more general argumentation-based dialogue framework. First of all, we have here data coming from a dialogue corpus, which is named inspired. The utterances, both of the recommender and the seeker, are represented as nodes connected by a followed by relationship, as we saw before. These nodes represent our personal common ground, or in other words, also our personal experience. Each node may also refer to an entity which is saved in the communal common ground. This knowledge comes from linked open data, as we mentioned before, and this linked open data can be, for example, IMDb, so the Internet Movie Database. Among the entities that we stored in the knowledge base, we have actors, directors, and movies. Movies can be connected to other sources, like this node actually represents a movie lens user. Movie lens collects the scores given as a rating to a particular movie. So there are all the users, they rated different movies. And we have here so the users and the rating for that specific movie. And then we also have the award, which is given uh, to, to the movie. And we have the plot. The plot, in this case, is in English, is also connected to other plots by is similar to relationships, giving us the possibility to instruct similarities among movies. And this similarity is computed based on plot embeddings. So it is based on textual embeddings. This is more or less what we have in the database. The database is really big and we are using it to extract many information and as we will also see in a bit. Okay, after Gandalf, we have Galadriel, and as I already mentioned, Galadriel refers to grounding strategies that are based to the representation of the knowledge as we saw it in Gandalf. And these strategies can be of different kinds. We can have the possibility to identify communicative problems, the possibility to elaborate appropriate clarification requests, or explaining decisions and reasoning, or selecting the most plausible arguments. In fact, we'll see later how in this argumentation-based dialogue framework, one of the most interesting things is to understand how to select arguments to recommend a specific item. We start here with Frodo. As we said, Frodo has the task of bringing mutual understanding using clarification requests. A clarification request is a tool which is used in interaction to maintain mutual understanding of the communicated message during the interaction, during the conversation. Starting with classification made by Allwood, we identified different specific basic communicative functions, which are contact, perception, comprehension, and intention. From this classification, for my dissertation, for my PhD, I identified specific level, communication level, like contact, perception, understanding, and intention, and I mapped on these levels possible problems, triggers, forms, functions, and compromised items that can occur in the interaction. We can now briefly look at one of the levels, which is the understanding level. For this level, we can have different problems concerned with lexicon, the reference to the constructions, the syntactic understanding, logical understanding, or information processing. For today, I will focus on just the information processing because I want to show you how we can use graphs to find problems in the information processing and how we can also generate the appropriate clarification request by using graphs. For information processing, we refer to problems that are concerned with the information communicated in the dialogue, especially when an information that entered the common ground needs to be verified. In this case, we talk about common ground inconsistencies that trigger the possibility to use a common ground clarification request. This is what common ground inconsistencies are. So we have common ground inconsistencies when an information which is part of our set of shared knowledge clashes with a new information provided by the speaker. Let's say that we have different elements that we use in our different entities that we refer to during the interaction. We can act upon these entities because we can use the entities in our actions, and these entities might have different states like preconditions and postconditions. If we need an element, an item that has a specific state, a specific precondition to be used in that action, everything works fine. We can use this item with this action. For example, grind the nutmeg. The nutmeg is solid, and I can actually grind it. But if after an action we have a post condition of this item, which is now from solid to powder, we cannot grind it anymore. We can no longer grind it. This means that in this case an inconsistency occurs, and for this reason we may use a corrective feedback like clarification request to solve the problem. So in summary, we can say that this conflict can depend on a precondition which is incompatible with the rules of the communal common ground, which is also represented by common sense. For example, the fact that the milk cannot be cut.
May I quickly add something here? This
Yes.
is very, very interesting, and because for us humans, I think this is a particularly easy thing to do. We just assume, or we make it work, but for computers this is particularly hard. I don't know if anybody, or if you saw that video that somebody, I think recently, or I don't know when I saw it actually, is this father, and he tells his kid, tell me how to do a peanut butter and jelly sandwich, and they give him instructions and he follows them verbatim basically. So, and it's it's very funny because he does what a computer would do, right? You tell a computer, okay, now put the, I don't know, cut the bread, then cuts the bread, and then now put butter on the bread, but the bread is already cut, so it's messy and all of that stuff. But if it's very funny, very interesting. As a human, you would then, okay, you get the instructions, yes, I know, I'll work around it so that the outcome works. But for a computer, it's they do one thing after the other, and then
Yeah. Yeah, and that's why we also use the cooking domain, because there you have instructions and you can also control the states of the ingredients.
Yeah.
And the other case is when the incompatibility of a precondition of the current action clashes with the postcondition resulting from a preceding action, which is already saved in the personal common ground. And here we have an example of how the conflict search graph was constructed, and how we could identify the conflict and generate the clarification request. So the first node represents the user. So we have a user that declares an action like, again, grind the nutmeg. This is a specific frame instance belonging to the cooking domain, and which is an instance of the actual frame of grinding, so the representation of its meaning. And in this frame, we have a frame element which is patient, represented by the object of this action, the fact that we can grind the nutmeg. Then we have the nutmeg here, which is the entity recognized, that refers to an entity, a perceived entity, which is the one stored in the knowledge base. This is stored with a specific precondition, the fact that the nutmeg, is solid. So the action is possible because it is solid, and we can we can create a new entity, which is now powder. Once we have another action, even after some dialog steps, some dialog turns, the action that again says something like grind the nutmeg, we recognize again the nutmeg as the entity, but we cannot connect this entity to the perceived entity, because now this entity does not have the precondition we are expecting to have to show. And we go back to retrieve which action caused this entity to be powder, so to change the state which is not coherent or consistent with the precondition we are expecting. And therefore we retrieved the previous action and we built our clarification request on this action, like didn't I have or wasn't I supposed to grind the nutmeg before? So we use a clarification request that focus the attention on that specific action that caused the inconsistency. Here we have an example of query that was used for the conflict search graph. This query was actually concerned with the availability of the quantity of the entity that was used in a specific action. So the quantity was checked. If we had zero quantity, the action was not possible, or if we had some of it was possible, or it also depended on the type of ingredient actually. And with this query, we can extract if the action is possible or not possible, and the response, for example, when it is false, is something like I can't. Then the explanation was also provided, like I don't have enough of this perceived entity. The conflicting frame, so the action that caused this conflict, was also retrieved, so we have the action. And then also the original entity was retrieved to build the clarification request, as I explained before. Now I can also show you a video. I think this was also showed by Antonio during its presentation. Let me, no, this is not working. Okay. Let me know if you can hear it.
I don't think there's sound, but
There is no sound?
no.
Ah.
But that's
Let me,
okay, I guess.
yeah.
Yeah.
Okay, so as you could see, after some actions, the conflicting action was
Yeah.
retrieved to build the, the clarification request. Sorry. Okay, now let's see what Smiggle is about. This is also a work in progress by another PhD student, Martina Di Pratto. And Smiggle represents, let's say, the pursuit of expressive school, which is manifested in linguistic expressions. So this part is an illocutionary completion that corresponds to what happens in argumentation. As I said before, one important aspect of argumentation is the capability of selecting the appropriate argument. And according to some scholars like Baglieri, data are selected as beliefs on the basis of their cognitive properties. There are different types of cognitive properties, like the ones we list here, so credibility, importance, relevance, and likability or unlikability. For example, credibility is the measure of the number of values of supporting data. The importance is a measure of the epistemic connectivity of a datum, or the relevance, the measure of the pragmatic utility of the datum, or the likability, a measure of the motivational appeal of the datum. And we identified specific measures that, like the ones shown in this slide, that can be mapped on these theoretical models, and that make also use of graphs to to be retrieved, to be returned. Among the various measures shown in this table, we point out a network analysis procedure with the HITS algorithms, which are also implemented in graph data science, and that attributes authority and up scores to considered nodes. Uh, for example, let's dive into this. There are scores like authority and hub, like the ones that are used in graph data science, that can be defined like respectively like the measures that indicate how many nodes with high hub scores point toward this node. So an authority score is a score with many up scores pointing toward it, and symmetrically, an up score is an up score node is a node that has many authority nodes that can be reached from the considered node. And then we also have other measures that we use, like for example, for relevance, we have the entropy or soft evidence, which identifies which relevant or less uncertain data needs a feedback to continue with the interaction. And we also have art evidence for likability. These measures are implemented in Motor. In this slide, we can see we can now focus on authority and hub, which are important for us because these are represented also in Neo4j. And as we can see from this slide, hub and authority scores can be mapped on importance and credibility in an intuitive way, because the graphs represented here are really similar. A datum is therefore considered authoritative when it has several data supporting it, like here. And a datum has a high up score when it supports other kinds of authoritative data. Okay, leveraging on these
How are we
measures.
looking on time, Maria? We have about 5 minutes left.
Okay.
Want to see.
Yeah, I think we are almost there. I
Okay.
hope yeah. I
Yeah.
just want to show you how this is done
Yeah.
in
Yeah.
Neo4j, and then I can briefly conclude. Yeah, now I will therefore show you why this is important and how this can be done. Here we have a query to retrieve the most authoritative and up nodes in the graph. For this example, I use the movie database, which is the database example for Neo4j. So of course there are the scores are not so high for some nodes as we might expect in another database. What we can see from here is that generally movies are the most authoritative nodes, because of course we have many other nodes pointing toward them. This means that being these nodes the most authoritative, they can be used, for example, for argumentative purposes. So if we want to find the most, if we want to explore the preferences of our interlocutor, we can use these nodes to extract important information. Then we have, for example, persons which are more up than authoritative, and of course persons point towards authoritative nodes. That's why in this graph we don't have John, which is conversely present in our database, and of course John is, let's say, a super node with the highest authoritative score, and this is particularly important to keep in mind, because when we explore the preferences of our interlocutor, we start asking the genre generally. This is something that we actually saw in the data by analyzing real conversations, and the fact that we can replicate this by using a graph, because genre is actually one of the most authoritative node in the graph, means that using graphs can really help us replicate something that happens in real dialogues. Okay. Just to conclude, I want to briefly show you how we use Mordor. Mordor, as I said, is the dark side of our framework, because our theory is here implemented with technology. And as I mentioned before, we have Treebeard and Samwise. I will briefly show you how Treebeard works. We have here sorry, we have here behavior tree, a behavior tree which is based on the configuration of our graph, and I'll tell you what this means in a bit. But as you can see from this part of the behavior tree, what we saw, for example, in Frodo, can here be represented. So we have the problems and the conflicts that we identified in Frodo, and for which clarification requests could be generated. And these clarification requests that we see here are based on a query, on queries on the graph. So graphs are used also to generate clarification requests and find problems in the dialogue. And this is also modeled in a behavior tree, meaning that the system always knows how to behave according to the configuration of the graph. With configuration of the graph, we mean that we can have specific set of problems or of goals, of pseudo goals also, that can be pursued by the system based on its configuration. For example, a graph can be interpretable if there are no communication problem. If a communication problem occurs, we can use a clarification request. Or if it is interpretable, it might be incomplete if some information is missing. For this, we can use a request for information. Or again, it can be complete and interpretable but not coherent. In this case, we can use the disambiguation question. Or it can be unstable when there are questions which are not answered. In this case, we can use question answering strategies. Or it can be desirable, for example, like for argumentation purposes, we can know when to go from exploration or exploitation according to the amount of information that we have already collected during the dialogue. In conclusion, we can say that linguistic analysis of dialogues can use graphs to enhance the performance of the results, to allow the study of how actually people access knowledge while talking, and therefore better represent them. A specific situation might be linked to the occurrence of specific linguistic phenomena, and this can also be represented with the use of graph patterns. As we saw, graph data science can also link dialogue analysis to mathematical concepts, supporting the development of theories. Linguistically motivated patterns can also be easily transferred to machines for explainable and lightweight dialogue management. Thank you for your attention. If you have questions,
Cool.
I'm there.
Thank you very much, Maria. That was very interesting. I can only copy what Anshu said. Fascinating work. We believe with much future applications in the industry. I think that's totally right. This is a good, you're laying the ground here for various applications around not only chatbots but more or less computer and human interaction, I think. So yeah, it's very, very interesting. yeah, I think we are at the end, and yeah, wrapping up now. So thank you very much for watching. Thank you for presenting, Maria. Thank you for taking the time and for giving us an overview of how to work with in the linguistic space with graphs, and how to apply them, and how to how to make them rule it all. I like the theme. That's it's a really cool touch.
Yeah.
Um, yeah, I'll be back next week on Tuesday. Is a morning session, European time wise. So because I'm talking to somebody who's living in Japan, and we would organize or we look at a graph app he's programmed for Teamfight Tactics, which is an online multiplayer game, analyzes with graphs. So that's happening on Tuesday. And yeah, I hope to see you then. Again, thank you very much for watching. Thank you, Maria.
You're
And
welcome.
have a good rest of your day. Good evening, everybody, and see you soon. Bye bye.
Bye.